Hi, welcome to our video on using a state machine in our Unity games. This is a project that we've been working on for a number of different videos, mostly to explore some more advanced game patterns. Although I think we also used it for UI basics. So it's Sokoban. It's a Sokoban game, and here's where we're at with it. We can move around. We can push blocks, push them onto goals. We have a timer. We have a move counter, which I added off recording. None of the previous videos show me adding that, but it's all pretty much there. Undo and redo, or sorry, undo and restart. Although we could add redo pretty easily. What we are missing is the ability to win the game. We have the ability to win the game. We have won. And we will keep winning every time we move. But nothing happens on screen when we win. So when you win, a number of different elements could respond to this event of winning. They could turn on a UI panel. They could disable player movement. They could play a background sound. They could initiate a little moving to the next level or moving an animated transition. There are all sorts of different systems in my game that might care about the current state of the game, being it winning, paused, or I think just those two, right? and being in gameplay or not. So we want to handle that in an elegant way. Our reflex is to head to the game manager script and maybe add booleans like has won, and then in our player input script we check if the game manager.hasWon is false before doing any input checking. Maybe we do the same thing in a UI block and we turn on a UI panel. We just check for that variable, and then we say, okay, that works great. We're good to go. And then we go and we try to add a pause feature to the game. And then we're copying and pasting some code, and it basically works the same. And now like 5 more things all need a reference to this one script, and it gets even messier. So then we say, okay, I know the solution to this. We'll use an event system instead of the booleans, and that kind of helps some things. It helps some update loops and all the other code to be prettier and easier to work with. But the game manager still has to touch everything, and it kind of forces our hand into a singleton pattern. And my gut instinct when I'm doing Unity development is to not get forced into an architectural pattern of any kind, but particularly not one that enforces a strong dependency in my project, like singletons. So how can we get around that? How can we have this piece of information that everything knows about, the game state, while not having it be in the game manager script? And the answer is scriptable objects. I sort of gave it away in the way I phrased that previous sentence. I gave away the secret. But if we turn instead of having the game manager tell everything what they need to know, or having everything listen to the game manager, instead we wrap up the idea of a game state, of the current global state of the game, into an object, into a piece of data that will make a scriptable object. And anything anywhere can just look at that scriptable object and be like, what's the state of the game? Game manager will look at that scriptable object and tell it to pause or unpause, tell it to start playing or not start playing, and so on. And anything else will go in and out of various states. So that state pattern, that flow chart of you have a piece of information that can only conceptually be like one thing at a time, and we move between them. That's sort of the high level pattern we're using. Although if I say state pattern, I don't think this is, actually it will be, but there are ways to do it with just like an enum and a scriptable object and not like a whole thing. We're gonna do it the fancy way because that's the point of these videos, is to raise our beginner intermediate level up to like intermediate level, maybe somewhat advanced, in a simple scope. So let's make a new folder for our state machine. And for our scripts, and we are going to make a new scriptable object that's going to represent our machine. And it's going to loop through what different states we can have. So let's add a scriptable object. Let's call it, I'll just call it state machine. I'm in a Git repository. You can look at all this code up on GitHub. That's what those pop-ups are. So let's call this state machine, and we'll put it in my little folder. I don't like in Unity, I don't like how big this menu is. Right, if you right click and go to create, like this menu is already pretty big. So I like to make, for all of my custom stuff, I like, 1, 2, maybe 3 little, my gameplay stuff, my utility stuff, whatever it is. I kind of put them all in a different thing. State machine should probably be its own folder. It's not really part of Sokoban. This is going to be a pretty general system that we could apply to many games. So I'll change that. State machine. Okay. So what is the state machine going to do? It's going to know about the current state, basically. And it's going to enter and exit states. So our state, the actual piece of data that holds a state, could be something like an integer. And it could be 0 for gameplay, and 1 for victory, and 2 for lose, and 3 for pause, or -1 for pause. Ooh, fancy. That's gross. That's ugly. We know better. We know that we should... Get out of here. We could do an enum to hold on to that state. And then now we can give them... we could give it or we don't really have a lose condition in this game, but we could write all of our states as an enum, and then the state machine could grab those. But we're not going to do it that way. We're going to be even one step fancier. We're going to have an object that is going to represent what the current state can be. It could be, it could be just a class that we have somewhere. That's a pretty standard approach of this play. It doesn't inherit from mono behavior or anything. It's just kind of its own object, and we can make a bunch of them and then have some code in that object. But we're going to go even one step further in the data-oriented design section. We're going to use a scriptable object to handle our state. And I'm going to call it state. And now using the little, whatever I called that folder. What did I call that folder? State machine. And now I can create actual states. These states right now are going to be empty. We're going to add some code, take advantage of the fact that we can, but for now they're just going to be these like data objects I can just like make in Unity and have. So we could have a current state class. Let's see what that looks like in if we make some scriptable objects and have it. If we go to my game data, let's make some new folders. Let's call one of them settings and put our settings in there. Let's make a new folder and let's call this one game state. And we'll make a new state machine. Game state machine. And it has a little public slot for a state. So I'm gonna make a new folder for my game states. Let's call it states. And we'll make a new state. And we'll call this one gameplay. The default state, you're just playing the game. And we'll make a new one and call it victory. And these are empty, they don't do anything, but they're here. And in my state machine, let me lock that. In my state machine, I can drag them in there or drag this one in there. And now our machine's starting to make sense. We can have objects reference this game state machine, and they can get whatever the current state is. Nice. That is convenient. And then they can use that to check on things and do whatever they want to do. So let's write some public functions for manipulating this game state. Let's set this to be private, and we'll do a little underscore there so we know it's private. We'll make a little public getter. What did I do? Current state. Whatever. I don't even know if I'm going to use that. What do you want to do? What is your convert to auto? Shush. This allows me to serialize this particular style of getters and setters. But this video is not about getters and setters. This video is about state machines. Okay, so we need a function that allows us to set the current state of the game. And we'll just get told what state to go into. And we'll set the current state to the new state. And that's kind of all we need right now. So with that, we can go to our game manager and we can make some public references to the, let's put them up top. State machine config, serialize, private, state machine. How did that? Serialize that. Okay, serialize private state victory state. And now in here we can do machine dot set current state to victory state. Right, when we win the game, we're just gonna change the state into the victory state. And then on start, we will take our machine and we will set it to the gameplay state. I'm actually just going to do a little init function here. Make a little public initiator. Let's put keyboard shortcut. There we go. Public initiator, which is going to set current state to a default state. Instead of having the gameplay have to know what the starting state is, we'll just have this little initiation function, because that tends to be useful for scriptable objects for like clearing your variables and resetting information and initiating things. It's something I think we end up tending to need is if we're using scriptable objects in a way that is like per scene load, that we need some objects in the scene that's like, oh, by the way, you don't get the event function, so let me tell you when to initiate. So we'll have that. We'll actually use set current state here to our default state. So now when the game begins, the machine will get initiated. It'll go to its default state, which we'll assign to be the gameplay state in the inspector. And then as we play, when we win, it should update. So we'll take our default state. We'll set that to gameplay. Beautiful. We'll go to our game manager. Unlock that. And we'll set our machine to our only machine. And we'll set our victory state to victory. And so if I select our game state, we see it says gameplay. If we play the game, and then hover my mouse over here to have it update. Did it not? I had to click off of it and back on. Ah, it didn't work. Why didn't it work? Victory. Oh, because I can't see what the current state is. I'm looking at the default state variable. Okay, let's make this public temporarily. Normally I would use like naughty attributes to have like a read-only field in the inspector so I could see it. I wish that was built into Unity by default. Okay, now I can actually see the current state. Hey, look, it says gameplay. And then if I win, hey, now it says victory. Huzzah. It actually worked. Wow, I'm going crazy. Need another cup of coffee. So now we can have objects listen to the current state. They can reference the machine, they can get the current state, and they can check when we enter and exit. When we do that, like checking, we're gonna want some kind of event system to fire off. Maybe we want to add an action to this or an event to this state machine that's going to have it get called on state change, and it's going to pass out the current state. We could have listeners to that. Oh, and if that state is my state, then I'll care about it. We're not going to do that. We may want to do that. We may want to have that feature there. It doesn't really hurt anything. But instead, let's actually go to our state object itself. And here, let's store some information when this state is entered and when this state is exited. That way, instead of listening to, I think for most of our objects that are going to be listening to the game state changing, they're only listening to one state. They don't need to know about every single change and then checking if that state is something they care about, because then they're going to need to reference two objects, the machine and the state. Well, why not just reference the state that they care about and have that state that they care about, because we can put code there, tell it things. So let's write an onEnter function and an onExit function. And we'll have these fire off some events of its own. So our state machine, we will, on set current state, if it's not null, we'll call onExit. I feel like we're going to get a weird issue where when I initiate the game, we're going to leave the victory state. It might cause some bugs. We might want to reset that in the init function. And then we'll take our current state and we'll call onEnter. So we'll leave the current state and we'll change it, and then we'll enter the current state. So the current state functions should always get onEnter called and onExit called. Nice. Again, because they're scriptable objects, this variable won't reset. Maybe we might need that. I'm going to leave that off and just see if we get the bug, see if we get those kinds of errors, because that's, if we're working with scriptable objects, it's good to be aware about our big getches and kotches and the disadvantages of scriptable objects being used in this way. So how can we get other objects to listen to a state? Well, let's do it the easy way for now, which is to use an action. Public action onEnter. And onEnter event public. OnExit event. We'll just call those functions. If they have any listeners, we'll invoke them. Nice. So now we need to listen to them in a game object. I'm going to write this code in an empty Unity script just to demonstrate it. We'll call it state change listener and a little mono behavior, just to demonstrate the code that we're going to have to move around to all of our different things that listen to our game state changing. So we need a state, and then on enable and on disable, we want to subscribe to that, and state.exit event. It's really important that we're going to have to subscribe and unsubscribe on disable, because our scriptable object will hold on to those. It won't get cleared when we leave play mode. So when we leave play mode, on disable will get called, and all behaviors, and on destroy will get called. So we'll need to use that. But this is the sort of the basic pattern that we'll have to put into all of our code. But the way I just said that might have raised a little red flag for you. It's like, maybe there's a better way to do that. Maybe we can use this and use object inheritance to take advantage of not having to write code more than once. I think so. Let's have these events be virtual. Probably gonna need to do on enable and disable too. But let's have these events be virtual so we can override them in the children and then just have anything that we listen to do its thing. So one of the things that we care about is player input. So instead of extending from mono behavior, our player input can change to state change listener, and we can only call input when we are in the gameplay state. So we'll make a little private bool can move. We'll just have it be true. I think Ryder wants me to make that have an underscore. When we can move, we'll move. And we'll just grab our input and block it. So if we can't move, return, can't move. So now we just need to update this variable with the state machine. So because we're listening to it, and because we don't use on enable or on disable, all we need to do is override on enter and can move equals true, because this will be the gameplay state. And we'll override on exit, and we'll set can move to false. Very simple. So we basically have these new event functions for our state. Let's see what that looks like in the game. We can go to our player. We can tell it to listen to the gameplay state. And we were able to apply that to the prefab because we can always reference these states because they're just objects in our data, in our game. So let's see if it works. I am no longer able to move. I've entered the victory state and my game has ended. Excellent. What else cares about the game state? Well, we could pause the game and unpause the game. But let's get back. Let's stay on the victory state for now, and let's head to our UI. I've created a panel in our canvas called paused. That will be that. But let's go ahead and duplicate it. And let's call this one victory, but we'll disable the image. Or no, we'll enable it and make it green and transparent. And then just put the text victory text. It will be you win. So we have our victory panel. Oh, that green on yellow is not good. I'll just make that gray out. You win. And change that to a square so I get my borders. Nice. So now I want to enable and disable this game object when we have won. Well, that feels like something I'm going to do more than once. So let's write a new little utility script here. Let's call it enable children with state. And we'll make this extend state machine state change listener. We'll override enter. We'll override exit. We shouldn't use the word event in there. I don't like that. Anyway. So now we just need to enable and disable all of our children. For each transform child in transform child dot set the game object dot set active true and false. Nice. So now I just need to make a base object that will be empty and have that object, and it will disable this image and it will disable its text. So I'll call this one panel, and then I'll make a new empty, and I'll call this one victory panel, victory text. We'll make sure this is like full screen. And then we'll give this one the game object. enable children with state, game state, victory. Maybe we do need it to leave the victory state when we start the game. We might have some bugs with the beginning condition of the game. We'll do the same thing for the paused state. We'll add an empty, we'll call it paused. We'll call this one paused panel. And we'll put it into paused, open prefab. Okay, we gotta apply all this stuff to the prefab. It's been a minute since I've done multiple prefab. I want to apply these to the canvas and not as overrides. Did I do that? No. Undo. Go to the prefab editor. Nope. Right here. Right where? Apply to canvas. Apply to canvas. Apply to canvas. Okay. Okay. So now in my actual canvas prefab, I have the states. So in paused, I should add enable with pause. We don't have a pause state yet. Bring that in there. Make sure this is just kind of an actual empty. And we can make a new pause state. Duplicate, call it paused. There we go. So let's just see what happens. All right, they both disabled, which is good. And then the win state enabled, which is great. Nothing else is referencing the game manager. I can't undo, I can restart, but I stay in the win state. Oh no! I knew I'd have a bug like that. We need the, what do we need? We need the listener to, on start, check if it is the current state, and then be enabled on start or not. Let's add a Boolean for current state, for is current. We'll just move it around in the state. And then on our list, on our enabled with machine, actually, in start, we can do make that protected so I can access it. But set them to whether or not we're the current state or not. In start, which makes me feel like I need to initialize the state machine in awake, not in start. But the bug went away. Can't undo, restart, and our enabling and disabling children objects are checking themselves. Because we may not get that exit event, right? You know, if we're already begun and the victory panel is enabled, or its children are enabled, we don't want that. We want to turn it off when the game begins. And since we're only listening to the victory state and we're not listening to the gameplay state entering, we don't have that exit for the victory state because it's just the beginning of the game. We'll just check its current state on start. That feels fine. It's fine. It's a little gotcha with scriptable objects, these kinds of bugs. Let's add the pause. How do we pause a game? Right, so the timer is going up. We need to control the timer. I exited play mode and I was like, oh, the bug's back. Okay. Let's add a little button. Restart button, duplicate that. Then move it to the left. And we'll call it pause. Pause button. And I'll have this one be centered. That feels okay. And what does a pause button do? It will pause the game. That's probably a game manager thing, right? Because the game manager is the timer. So we probably need to add a pause and unpause feature to the game manager. So we'll need to know what the pause state is. And then we'll add a little public void pause, public void unpause. And when we pause, we will set our timer. Do I start it or I resume it? Unpause it. It's called unpause. Okay. And then I will set the current state to the gameplay state. I don't have a reference to gameplay state because I didn't want to reference to gameplay state because I use defaults, but we need to know we can't go to the previous state. We can't return to previous state because we wrote too simple of a state machine. It's really nice to keep your states in a stack in your state machine. And then instead of setting current state, you can just have go back. Because really often we want just pause, unpause, and then victory. Right? We don't actually need to know what the current state is, or, we really don't like this I have to know about all of my states in one script, because at this point, you might think well, we don't really need this entire whole setup. It could just be in the game manager. And then it could. This project is at a level where it's simple enough that we can get away with the simple codes and we can see some of the ugliness, where more complexity would help, like having a list for just going to the previous state, having pause be controlled somewhere else and just have the timer listen to it. But we're trying to keep things simple. So it's kind of a balance of that. It works. Go to previous. We're not going to write that, but we could pretty easily. So now when we push this button, we will pause and then apply this as an override to the canvas. And then in the pause menu, and it blocks out the screen so you can't see what you're doing. We'll add a button. Resume. And the existence of the pause button will be part of the canvas prefab, and the assigning it to the game manager object will need to be a part of the manager's prefab. So let's make sure we can do that. Zoom button. I think I did it right. I don't know. I don't use nesting prefabs very often. Pause. And we're not set to an instance of an object because I need the gameplay state to know about these things. The game manager to know about these things. There we go. What's nice is you can just do that once and then be done with it. Pause. And because I left the play state, I shouldn't be able to move. Resume. And victory. So my timer, 1, 2, 3, pause, wait a few more seconds. It should be at 5 or 6. It's still at 3. Our timer successfully paused. I don't think I ever tested that code. And our timer still runs when we win the game. We're not using the state machine to control the timer. We're just using, I'll just pause it. I don't remember if the stopping it will reset its values. Where's my timer? It will, okay. Maybe we should stop. It doesn't really matter, does it? It'll need to get restarted, reinitialized before we can check. Now it's impossible to I don't know, it doesn't really matter. 3 seconds. 20 turns. All right. Well, that's it for the video. Hopefully you saw some of the trip ups that can happen with using scriptable objects in a way, but also some of the nice elements. You know, we can just check this is current value of a state. We don't need to use a base class here. We don't need to generalize that code. Maybe we only want on enter or on exit. You know, what else might use the state code? We could put unity events in the state and then call functions on other scriptable objects and other bits of game data. You know, have a lot of piping connected without being part of a scene. 14 moves, 2 seconds. Look at me go. That's it. So we're using, you know, it's a little bit more advanced than using like an enum in our game manager. There's still some cleanup to be done. There's still some features like that. Frankly, our machine could probably know about all the different states, and it could have some nice little utility functions like victory or return to default, things like that. And that would save us from having to serialize this in a game object. And we just, you know, we're setting up our machine in the scriptable object. That's a more reasonable place to put that code. And, you know, having it be this perfectly generalized solution that I could bring to other projects, like I don't need that. I could just make it work for this one and write these little utility functions that I set up in my machine. There's no reason to have the game manager need to know all that stuff. It's just like one more kind of point of failure. The state machine might as well be responsible for those things. But as is, it's a perfectly generalizable solution. You know, it's a little lacking in features, but it's as far as demonstrating such a thing, I think useful. So there we go. How do I hide my scene? Hide my managers. All right, that's all I got. Hope you enjoyed.